Functions and function notation will actually take you through the journey of grade 9 to grade 11 to understand this concept with the help of an example. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to understand the concept of functions and functions notation with the help of a very simple problem. A problem which you have seen so many times while working through linear applications. Well, in grade 9 also you came across this particular question. I'm going to start from here and then take your journey towards learning all the concepts and getting you to grade 11 or even grade 12 level functions. So basically, in this particular video, we are going to not only understand the basics about the given question, but see it in a very different perspective. As you can see here, we are given that a company rents car for $60 per day plus $0.20, means 20 cents per kilometer. Maximum distance per day is limited to 1,000 kilometers. Now, based on this equation, we could have many problems. You must have solved them, right? So you can have a look at these questions. Question number 1, A, B, C, D, E, F, G, H, and I. So as you can see here, so a couple of them up to kind of here, we have already done in grade 9 and 10. And then all of a sudden, we get into question 1F, where we need to write the cost per day, C of D, in function notation and then work on function notation. Let us see how all this is connected, right? And at the end, we're also talking about inverse of a function. Do you see that? So basically, the questions which we have solved so far, now, when we want to work on function notation, we need all that knowledge. And now, we'll see how that knowledge can be very useful to understand first the concept of function notation and then moving forward how easily we can actually do this subject. So treat this as an introduction to functions 11. So let's begin with the basic concepts which you are very clear about, but we'll give it a second thought now. So we say a company rents a car for $60 per day plus 20 cents per kilometer. Maximum distance per day is limited to 1,000 kilometers. Question 1A. Define the independent variable D and dependent variable C. So, well, you know, what is the independent variable here? So, in this case, independent variable is what? Independent variable is the distance covered per day, right? So, because we are given the rate, 1 day distance covered as 20 cents. So, we'll call this independent variable as D. D is distance in kilometers. You can say per day in kilometers, correct? So that becomes the independent variable. Now, based on this independent variable, we have the dependent variable, which is the cost, right? So the dependent variable is the cost, right, which is in dollars. Now we need to write the equation relating above variables to find the daily renting cost C. Mind it, it is asking for daily renting cost. So every day we have a fixed cost, which is $60 per day. You get the idea. So you could relate with the equation which you learned earlier, and that was what? Well, that was the dependent variable is equal to the rate times independent plus the starting value or the fixed cost. We also say initial cost, as this is a linear function. Well, most of you are familiar to this equation which is written in the form of y equals to mx plus b, right? So that is the form in which you could actually represent this equation. Now, since I have defined the cost as c, which is dependent on the distance traveled d, my equation will be what, right? So let me write down the equation now. So equation will relate the cost c to the rate, which is 20 cents, times the independent variable d plus the initial cost of $60. Make sense? So that is how we'll get our linear equation as the solution for the given situation. So that is how we have converted that sentence to an algebraic equation. Perfect. Now let's look into part C. It says sketch the graph to describe the meaning of rate per day and rate per kilometer, right? So remember, we got our equation as rate per kilometer times the distance plus rate per day, which is 60, correct? Now, if you are given this equation, how will you graph it? Well, you can see that the independent variable is d, the dependent is c, correct? C is in dollars and d is in kilometers. Perfect. So now, we can actually, let me write kilometers at the end. I'll need that space. Perfect. So we know d is the distance in kilometers and c is the total cost per day of driving. So we can now sketch the diagram here relating distance traveled per day with the cost. Well, if you don't drive at all, then it is $60. So let me say each is 20 division. So the third division here will be $60, right? So I made a scale of $20 each, right? This is 20, 40, 60, correct? Now, if I travel a distance of, let's say, 100 kilometers, then it will cost me $20 more. You get the point, right? So 0.20 is the gradient, right? Or the slope. So this slope is what? So 0.20, which is the slope m, means it could be 20 over 100. You get the idea. So we can go up by 20 for every 100. So that is how we could go, right? So 20, 100. Do you see that? 20, 100, right? So that is how we could actually go up the scale. So that means I'm taking this division as 100 now. 1, 2, 3, 4, 5. So that is 500 for me, right? So at 500, I'm at this point. And then again, 1, 2, 3, 4, 5 more. So that is maximum 1000. So I'll go up each time by 1, correct? So we reach at this point. Do you see that? So we can connect them with a straight line. That becomes the relation between the cost, how it is dependent on the distance traveled. You get the idea, right? You could also calculate, for example, if distance traveled is 1000 kilometers, right? In that case, the total cost will be 0.20 times 1000 plus 60. That is 200 plus 60, which is 260. So we get to this particular point, which is, you can say 1000 kilometers and $260. Make sense? So that becomes the representation. So now, I think you have understood the basic concept, and that is that the initial value gives you the fixed cost when the distance traveled was 0, right? For every 100 kilometers, you pay $20 extra, and that is how you get your graph. And since you are allowed maximum of 1000 kilometers, that is your maximum value for the day, covering distance of 1000, right? And paying $260. Perfect. So I hope this is absolutely clear. Now let's answer the other question, which is determine the rent determine the rental cost for driving 125 kilometers? Well, we have the equation, cost being 0.20 times distance plus 60. So if I put driving 125, that is d is equals to 125, I do get the answer, which is C is equals to 0.20 times 125 plus 60, correct? So you get your answer. So you can multiply by, let me write it back here. So we get the value of C as equals to 0.20 times 125 is, so 2 decimal places when you say, right? So you can double this up and $25, correct? Plus 60. So you get 25 plus 60, which is $85. And therefore, you have the total cost as $85. Makes sense? For driving 125 kilometers. Perfect. Every 100 kilometers gives you $20 extra, and then 25 kilometers will give you 5 more. You get the answer, right? So we get question number 1D in this particular fashion. Now let's look into 1E, which is determine how far can car be driven for $100. Well, now let's do 1E. So total cost is $100, and we need to isolate the distance D, right? So taking 60 on this side, we get 100 minus 60 equals to 0.20D. And then we know 0.20D is equal to 100 minus 60, which is 40. And the distance will be 40 divided by 0.2, you can say, or 400 by 2, right? So which is equal to, you can say 400 by 2, right? Or 200 kilometers. Make sense? So that is how you could answer this part. Not difficult at all. All this we had been doing since grade 9. So we know it, right? Perfectly fine. Now comes the question on function notation. It says, write the cost per day, C of D, in function notation and find C of 1000. In a way, we have answered this question already, right? So in function notation, what we really do is that we write the independent variable in terms of the dependent variable. So cost for distance traveled, right, will now be written as in a similar way as we did earlier, right? But it has a different meaning now, and the meaning is that this is the cost for distance traveled. Correct. Now, if you have to find what is C of 1000, it really means what? Just plug in 1000 here, right? As we did earlier also. So we have 0.20 times 1000 plus 60, and that gives you 260, correct? Dollars. So that is how we are going to answer question 1F. I think it is very clear to you, right? This is function notation. Just replacing that dependent variable by a name, and this name we call function notation. Now question 1G is find domain and range of this particular function. So domain and range really means what values of D are permitted, right? So we can write domain as, we know that the maximum distance covered is up to 1000. Of course, 0 is minimum, right? So domain is what? So domain is that the value of D can be from 0 to 1000. Is that clear to you? And now let's write down the range. Well, range is what? If you do not drive, even then you pay, right? You pay $60. And therefore, the range, which is the cost, will be between $60 to $260. Is that clear to you? So that is how we get domain and range of this particular function. Perfect. So this is what we deal with when we talk about functions and function notation. Perfect. So I hope this concept is clear. We'll move on and take a few more questions. But in case you have doubts and you want to learn more, you can always send an email on the address given. Well, let's look into the part H, which is find C inverse of D. Find and explain its significance, right? Now here is a very interesting part. We'll try to find the inverse of the cost, right? And then explain its significance. We have already seen that the cost with reference to distance traveled is equal to 0.20 times the distance plus 60, right? To find the inverse is reverse calculation, right? So it is inverse, which means inverse, reverse calculation. Let me write reverse calculation, right? Means if I drive 100 kilometers, then what cost you are paying, this was the relation. Now if I pay $100, how much can I drive, right? So this really means the inverse. So we'll isolate, right? So we can now isolate D, right? So we can say C of D minus 60 is equals to 0.20 D, right? Or 1 over 0.20 times the cost per kilometer minus 60 is D, right? So we got the inverse. 1 divided by 0.2 is in fact 5, right? So 5 of the cost minus 60 is D. So we have the equation for the inverse now, which you could write like this, or you could write C inverse of D. Is it okay? And C inverse of D is basically the cost in dollars, right? So cost in dollars minus 60, correct? Times 5. So that is what it is. And now you know cost in dollars to be paid is minimum 60 and makes sense. But if you pay more than 60, you can drive a bit. Otherwise, you cannot drive. You get the idea. So the question here is, find the inverse and explain its significance. So what is the significance? Can you now tell me? Significance is how much can you drive? You can say how many kilometers can be driven for a given amount, which is C, right? That is what it means, correct? So we'll understand this over the last example, which is we are given that the amount is $110, right? And find using the inverse, C inverse of D. So that basically means distance that can be driven for $110. That is what it means. You get the idea, right? So in our equation of C inverse D, let's rewrite the equation, which is equal to cost minus 60 times 5, right? Let me write 5 here. So since we want to find C inverse of D for $110, we'll say 5 times 110 minus 60, correct? That means 5 times 50, correct? And that gives you 250 kilometers. Is that clear to you? So 250 kilometers can be driven for $110, right? Does make sense. So that is how we relate all these things. So I hope with this example you have understood that what we had been learning so far, simple linear equations, and similarly quadratic or polynomial equations, all those word problems can now be represented in function notation terms, right? And we can talk about the function. We can talk about domain and range of these functions, and then we can also find their inverse and work accordingly. So I hope this video makes you understand the importance of this particular topic and lays a good foundation for the functions and function notation. Feel free to write your comments and your suggestions. If you like and subscribe to my videos, that'd be great. In case you want to learn from me, you can always send an email on the given address. Thanks for your time and all the best.